Welcome to our presentation on harmony cognition by neural transformation and analysis by EEG following the lines of Carl Stumpf. Let us start with a brief review of Carl Stumpf's Tonpsychology. Stumpf assumes that listeners recognize whether one or more tones are present in the musical sound. Perception of musical harmony arises after a process of tonal fusion. This means sensation of several tones results into a single impression. In consequence, musical harmony is more than the summation of interval consonants or dissonance, following a principle of Gestalt psychology. From introspection and experiments, in particular with musically not trained persons, he deduces the degree of tonal fusion. For instance, the degree of the octave is very high, as can be seen on the right of the diagram. Carl Stumpf formulated several rules of tonal fusion. First, tonal fusion depends on frequency and is independent of the tone region and loudness. Second, small deviations of the frequencies do not produce a noticeable change in tonal fusion. Third, tonal fusion remains even if both sounds are not offered to the same ear and even in the mere imagination. Interestingly, modern research in hearing, acoustics, and music cognition support this. And one could say that harmony perception more or less corresponds to approximate periodicity detection in the brain. So periodicity detection more or less corresponds to rule 1. The approximation process corresponds more or less to rule 2, and that the process takes place in the brain more or less corresponds to rule 3. How can periodicity be determined? Let's look at an example, namely the major triad in root position. We have an harmonic series presentation with the frequency ratios 4 to 5 to 6. And if we look at the tone components and their waveforms, it looks as shown on the 3 figures here. If we look at the superposition, we can recognize a periodic overall structure. After 4 times the period length of the lowest tone component, the pattern repeats again and again. And this factor 4 is called the relative periodicity H of the harmony. It is the approximated ratio of the period length of the chord relative to the period length of its lowest tone component. It corresponds to the minimum of harmonic series presentation, and it does not change if harmonic overtones are present. The claim, which has been investigated in earlier work, is that perceived consonance of a harmony decreases as periodicity increases. And the research question we want to address in this talk is, can periodicity pitch frequency be observed in the brain? And this is the topic of the second part of our presentation.
I did the related EEG experiment to investigate the perception of the periodicity pitch. So we examined the responses of the human brain while hearing randomly arranged variants of 7 stimuli. We chose synthesized tuba sounds because the timbres of tuba and trombone-like instruments are known for a good perception by the human brain. We examined the perception of triads with a ground tone G3, which has a frequency of 197 Hz. The chosen stimuli were G major, G minor, G diminished, and G suspended in root position, G suspended in the first inversion, and G major and G suspended in the second inversion. To get an impression of what we put our participant through and what they had accomplished, you now hear a short example sequence of the experiment. This sounds like fun, doesn't it? The experimental design contains a sampling rate of 10 kHz, the stimulus duration is 300 milliseconds, and the interstimulus interval consists of 100 milliseconds. The repetition rate per stimulus was 1,500 times, so we can get a good average out of all trials. I measured 15 healthy adults, 2 males and 13 females, with an average age of 21.6 years. The responses were recorded using an EEG system with 32 active electrodes. Once all measurements were done, we did a bandpass filter on the responses in the range of 15 to 700 Hz. Trials with a larger activity than plus minus 35 microvolt were considered as artifacts and rejected. All responses were averaged, and an absolute baseline correction was performed on this average, followed by a fast Fourier transformation. The results show clear peaks in the present stimulus frequencies. The more dissonant the triad, the smaller are the deflections of the stimulus frequencies. The periodicity pitch occurred in all responses related to a triad in root position, the G suspended in the first inversion, and to C major in the second inversion. And now we have a look at some frequency spectra. In blue, you can see the stimulus frequencies, and in the red line visualizes the response. We begin with a C major in root position, where you can see the present stimulus frequencies: G3 at 197 Hz, B3 at 248 Hz, and D4 at 294 Hz. The periodicity pitch occurs at 49 Hz, and you can also clearly see the double of it at 98 Hz. The first peak at approximately 18 Hz is considered as muscle artifacts. A much more dissonant chord is the G diminished in root position, with a third octave stimulus frequencies G at 197 Hz, B flat at 233 Hz, and D flat at 278 Hz. The periodicity pitch is clearly perceived at 39 Hz, but also lots of the interactions of the stimulus frequency. For example, the subtractions D flat minus B flat. A very interesting chord is also the G suspended in root position, with G3 at 197 Hz, C4 at 262 Hz, and D4 at 294 Hz. The periodicity pitch at 33 Hz is nicely perceived, also lots of its multiples. The first peak, again at 18 Hz, is considered as muscle artifacts. To conclude, we showed that the human brain shows the periodicity pitch frequencies of triads and that it can be calculated theoretically beforehand by means of the ground tone frequency and the relative periodicity of the harmony. The results reveal one step of encoding music perception in the human brain and are in line with Stumpf's theory of tonal fusion. The next interesting question we want to examine is if there is a difference in the amplitudes of the chosen stimulus frequencies independently of what chord is presented right before. Thank you for your attention.